Hello, welcome back to our Ironbug tutorials. And in this video, we are going to cover the heat pump systems. In our previous video, we have covered the hydraulic distribution system, which includes hot water loop and the baseboard as a zone equipment. In today's tutorial, we are going to cover several types of the heat pump systems. This is the one application that we can see. It uses the heat pump to generate hot water and uses hot water for different uses. For example, like radiator, a baseboard, or underfloor heating system. If we ignore the outdoor unit in this case, by only looking at the interior loops, you can see it's very similar to our previous hydraulic distribution system. The only difference here is here we need a boiler to generate hot water from the natural gas or electricity, but in this case, we are replacing the boiler with a heat pump. And on the right, this is a detailed diagram for the outdoor unit. We can just ignore what this outdoor unit does internally for now. All we need to remember right now for now is to remember this outdoor unit generates the hot water for the internal use. And now let's just open the same example file from the last tutorial, which is like I'll rename this one number 4 heating baseboard. Okay, this is the file we got from the previous video, and you can see. Let's briefly review this again. So we have one baseboard as a zone equipment for each thermal zones, and we also have the hot water loop. We can use group with Control G, and then I'll change the color to red to ensure this is like hot water loop. And maybe I wanna also use a label it hot water loop so that we can read it easily for the next time. Okay, now let me just save as level 4 heat pump. And okay, now all we need to do is use a heat pump to replace this boiler here. In this case, well, how can we get to the air source heat pump? One of the easy way is just type in heat pump. You can see there are several heat pump systems, like components named with heat pump. So this is heat pump water to water system, and there's central heat pump system, heat pump for the heating, and heat pump for the cooling, air cooled. So this is basically what we called air source heat pump system. So another easy way is just use the HVAC template. From here, IB HVAC template, and then right click pick a system. Underneath the other, you can say if you have installed the latest Ironbug, here there is a new template added to this number 3 other group. So the first one is the air source heat pump. So once you click, it gives you this template. If you're just looking at this template, it gives you both the chill water loop and the hot water loop. But in this case, all we need is the heat pump to generate hot water. So for my demo, I'll just copy this hot water side, Control C, Control V, and disconnect this to water side. All right, so this is what we need to integrate with our existing system. Now let's look at the hot water loop here. So this template has a pump and plan branches and then separately manage schedules. This is all we have here as well. You can see a pump and plan branches and then separate manager scheduled. Now you can see the only difference here is, well, of course the heat pump will be different, but another one is supply hot water temperature. So in our original hot water loop, we are supplying 80 Celsius hot water, and in this template we are it is generating 54 Celsius. This is because typically the heat pump system cannot generate such high temperature hot water. And of course, we can just run a test with 80 degree, see if this heat pump will generate such high temperature hot water. Okay, so the easiest thing we can do here is just remove everything related to the boiler. Okay, boiler. This is the boiler output, and just connect the heat pump to plan branches. All right. Now we don't need this one anymore. Just delete. Simple. Okay. Or maybe I don't want to delete the boiler for now. We can just Control Z. Okay, now it's still connected to the existing boiler. Let's run a test for now so we can see the difference between the boiler and the heat pump. So this is the simulation we are running with the boiler for the baseboard. Okay, so I see this one is taking a little bit time to read. So we don't need the room air temperature for now. So the total EOI is 77 right now, and heating is 8. Okay, and yes, we have calculated the total system efficiency. It's because we are using the condensing boiler right now. The efficiency is pretty high than the regular traditional boiler. Right now it is 83%. Okay, now let me disable the simulation and let's run the simulation with the new heat pump. Delete, and replace with the heat pump. Don't need this one, delete. Okay, and Control S, save, and run again. Now, if you remember the previous result, it was 77. Now it drops to 71, and then the heat pump side. But previously, the boiler was the heating side is like 7 or 8. Now it's 2 for the heating UI, and the efficiency, yeah, because we don't use the boiler anymore, so we have to replace this output variable. How can we do that? Let me disable this one first. Let's heat pump. Let's request the output by holding the shift, so we can connect both object parameter and the output variables to the parameter. Okay, so heat pump electricity rate Toggle, Boolean toggle, set to true. So this is output variable. I'm going to copy. So we don't need this boiler. Okay. Control S and run again. Okay. After we replace the heat pump electricity rate, we get the, so this is the heat pump. The input rate at the peak hour, and this is the total, the baseboard heating rate at peak hour. Once we divide this output heating rate by the input heating rate, we get this 3.12. So how can we explain this one, this efficiency? We are using 1 unit of the energy. It generates 3 units of heating energy. How does that make sense? So because if you remember the first tutorial, I explained the first law of the thermodynamics, which is energy cannot be created and destroyed. So how is this possible? Now let's look at, before checking the system and making conclusions, we have to check if any of the zone has unmanned hours. So since we have already requested the unmanned hour for each zone, and we can see, visualize them. Okay. So this, we have 1, 2, 3, 4, 8, 4, 5, 6, 7, 8 zones, and we have explained why it has some uncomfortable hours. It's not probably an hour, it's like 0.17 hour. I believe it's like 10 minutes. There are several hours throughout the year. You can see typically starts from the beginning of the morning. It's slightly uncomfortable, but the rest of the year it's fine. So this is one of the disadvantages by using the hydraulic system. And we have covered this part in the previous video, and now we can just assume this is all fine. And because we don't have the cooling system, there are a ton of unmanned hour for the cooling. And baseboard total heating rate, this is fine. This is all fine. Let me see the base heat pump electricity rate. Okay. With the pump electricity rate. This looks fine for me, because you can see pump electricity rate matches the heat pump electricity rate. The pattern, they are matching exactly. And the minimum value is 0. Minimum value is 0. That means those hours is not running at all. So for now, it looks all fine. And now let's go back to the script. Go back to the question. How is that possible that we got almost 300% efficiency in this case? So let's go back to the slides. Now we have to look at this diagram more closely. And let's say we have basically two main parts. One is evaporator and condenser. In this case here, the fluid inside this system is using the refrigerant. To explain how this system, heat pump system works, now it's better to look at the refrigerator because it's using same principles. And we can see the purpose of the refrigerator is cool the internal space, right? And I don't know if any of you have ever touched the back side of the refrigerator. It gets pretty hot. That's because there's a compressor underneath the refrigerator. It constantly creates a hot compressed fluid and then use a fan to reject those heat to the air. And then once it goes back to inside the refrigerator, it gets cold again. There is an expansion valve to make the refrigerant super cold, which can absorb more heat from the internal space. And then it goes into the compressor again and becomes a very high pressure gas, hot gas, and then we get continue another cycle. So this, if you look at the same diagram here, it's basically the same concept. And in order to get the hot water, we are basically cooling the outdoor air. This is what a heat pump does. It's using very minimal electricity for the compressor to move the heat from one side to another side. So it doesn't generate heat. What it does is it's moving heat from one place to another place. In our example, we are using 1 unit of the electricity for the compressor, and then we get equivalent 3 units of hot water, 3 units of the heat energy inside of hot water.